Hey everyone, so Mrs. Slauson, and we are going to get you ready for the Showcase of Learning. But if you're watching this, chances are you probably aren't here to even take it yet. But anyway, I am in the skinny packet. I am on page 7, and we're just going to walk through these two examples to get you ready. So when we were in class together, or I'm sorry, remotely, we did the one on page 6. We did a linear one, and now what we're going to do is we're going to look at the exponential one. So again, I'm on page 7 in the skinny packet. So first thing I want to do is just remember that this is x and this is y, this is my dependent and this is my independent, and this is about the number of crimes in a city over 15 years. And what I notice is that the crime is going down, every 2 years, or sometimes it's every 1 year that I'm looking at the data. And so what happened was somebody went into Desmos and they put this into the table, and they put these numbers in the table, no commas, and the request was to look at it exponentially, and that's the equation. And over here, it's just saying F is the number of crimes, so this part is the number of crimes, and it says that X is the years since 1990. So if the year were 2020, I wouldn't put in 2020 in for X. I would see how many years that is after 1990, and then put that number in. So that would be 30 in this case. So again, what we're going to look at is identify the y-intercept, identify the growth factor, which it should actually say the rate, and then we're going to be using the equation. So to identify the y-intercept, that is the number that's more by itself because this number is next to x. And I do want you to remember that anytime we talk about the y-intercept, b is by itself, but b is also the beginning amount. And since it's the y-intercept, I want to look at the y values, what they are all representing. So this is the beginning number of crimes. So in this case, in particular, 1990 was the beginning, because that's when all my data started, since 1990. So according to my table, it's close to 14,000. According to the equation, it's still close to about 14,000. But it's a little bit different because this is trying to fit all these points, and it's just not going to fit it perfectly. So now I go for the growth factor, which in reality, I really want the rate. So that's the other number. So G is this 0.83, and you have to remember that G comes because they took 1, and then they either added the rate or subtracted the rate to get to 0.83. And so if I think of money, and this is 83 cents, and I start with $1, then I would have had to subtract that rate. And so to figure that out, just 1 minus how much is 83 cents, I could also just go to my calculator and type that in. Just the bigger number minus the smaller, and I'll see that R is 0.17. So my percent is 17. And again, this is a rate. Something is changing. What's changing? The number of crimes. How often are they looking at the data? Every year, technically. So that's what a rate is. It's always out of 1. So I can say the crime rate is going down, decreasing 70% each, every, per, something like that, year. Okay? It's always a rate. What's changing? Look at the whole thing, even if it's slope. I could say if this had been a number, let's say it wasn't a percent, my crimes are going down by 17 every year. So every year there are 17 fewer crimes, but in this case it's 70%. So the last thing is, what does this mean? So this is a trip back to chapter 2 where we learned about function notation. So I'm just rewriting the equation here. And then I would have drawn the wall, and I would have said, okay, 20 is in parentheses, so 20 needs a hug. So when I put 20 in, do I want 20 to go on the left or 20 on the right? And since 20 is in parentheses and it wants a hug, it wants to go where all the other numbers are. So I'm writing down what I would be typing into my calculator. Whoops. And let me show you what that looks like. So here it is. I just make sure it looks right, and then and you can do this in Desmos too. I hit enter, and that's my answer. So what does it mean when I get that? Well, we would have written our answer, my function when x is 20 gives me an answer of 336, and then I'll just do what they've been asking, going 3 numbers behind the decimal. But what this means is x, that's went in for x. So in 20 years, I don't know why I didn't write the number 20, the number of crimes is about 336. So now in 20 years, I was having almost 14,000 crimes per year, but now we're only down to about 336 crimes after 20 years. So next one is also going to be done exponentially. So this is after a person takes medicine, the amount of drug left in the person's body decreases over time. An experiment was conducted on a new prescription drug. So again, somebody went to Desmos. These were the X's. These were the Y's. The amount of drugs that's in my body depends on the hours. So again, Y is always dependent. So here, again, I realize this is a little bit hard to see, but they use exponential. So I'm just going to follow that format. This time I have to write the equation. So just in for A, going with my rounding rules, I would keep it at 709. And then for calculator purposes, we always put B in parentheses, 3 numbers behind the decimal, rounding. And so this is the equation. Whenever it says write the equation for the curve of best fit, line of best fit, you got to take this stuff and put it into the equation format that they give you. So we're going to do the same thing. What's my y-intercept? Well, that's my beginning. And then since it's y, it's the beginning drug amount. And I know that B is this 991.709, and I will label it. But again, it's a y-intercept. I know what everything that's y represents. According to the table, it's 1,000. And this is close to 1,000. So that should make sense that these are close. And again, the growth factor, that's the other number. But again, I don't want the growth factor. I want that G comes from me, in this case, subtracting the rate. So if I have 89 cents and I had $1 to start with, how much did I subtract from $1 to get to 89 cents? Again, I could just type that into my calculator. And otherwise, 11 cents. And then that as a percent is 11%. And again, it's a rate. Something's changing. What's changing is the amount of drugs I have in my body over a period of each hour. So, the drugs, the medicine is decreasing. And I know it's decreasing. I can see it here too, at a rate of 11% each hour. Okay? All right. Those are your notes to get you ready for your showcase of learning.